in this video, we're going to take what we learned about rotations in plane space and apply that knowledge to the coordinate plane. Now, first important big key idea that you need to take away with you from this video is that unless otherwise specified, rotations are always going to be done in the counterclockwise direction. So I'm going to get my highlighter out and highlight that. So that's just a very, very important thing to know. So in looking at the pictures of the clocks that are put there on that page, counterclockwise direction is going to be a positive number of degrees. And I bet you can probably anticipate what the clockwise sign is going to be. Anytime we see a negative number of degrees, that's going to be our indication that we're going to turn or rotate in a clockwise direction. So again, a positive number of degrees tells us that the movement or the turn is counterclockwise, whereas a negative number of degrees tells us that that turn is going to be performed in a clockwise direction. Now the notation for a rotation is also important to take note of here. Whereas we use a lowercase r to represent a reflection, a capital or uppercase R is used to indicate a rotation. So it's really important that you pay attention to details because again, lowercase r represents a reflection in a line, uppercase R represents a rotation about a point. So that uppercase R is our indication that the transformation that we will be performing is a rotation. The ordered pair right there tells us the center about which we're going to rotate. And the last number tells us the number of degrees that we're going to be performing the rotation. Okay, so let's go ahead and let's rotate some points in the coordinate plane. You did this back in middle school, so hopefully this is a little bit of recollection or recalling what you did in middle school. I should say too that on the video, I think this can be confusing, but do pay careful, close attention, and then if you have concerns or if there are things that you don't understand, we'll iron them out when you come back to class. So in this example down at the bottom of page 14, we're given some point P with coordinates 4, -3. So the very first thing I'm going to do is I'm going to go ahead and plot point P on my paper. If you haven't already, I want you to go ahead and plot point P also. It's going to be very important that you plot the points because what we're going to do is we're going to plot the points. We're going to turn the paper the required number of degrees. And then once we turn the paper, we're going to see where that point ended up after we performed the rotation, after we did the turn. Okay, so in part A, it says find point P prime, which is going to be the image of our point P after a rotation about the origin of 180 degrees. Now this is where it gets tricky because I can't physically turn my paper on the smartboard. So what I'm going to have you do right now is take your paper. The 180 degrees is in a positive direction, so that means we want to go 180 degrees counterclockwise. So go ahead right now, turn your paper 180 degrees counterclockwise. Okay, and when you turned your paper 180 degrees counterclockwise, what I want to know is, where did point P end up? What are its new coordinates? So if I look at my paper, which right next to me is upside down right now, I'm looking at that and I'm seeing that point P ended up at the point now whose coordinates are -4, +3. And because point P ended up at the point whose coordinates are -4, 3 after a rotation of 180 degrees about the origin, that's going to be the new coordinates of point P prime. All right, go ahead now, flip your paper right side up. And now that your paper is right side up, you can go ahead and plot point P prime. So P prime ended up right there. Okay, in part B now, they want us to find point P double prime, which is the image of point P after a rotation of around point 00, the origin, of 90 degrees. And again, because that 90 degrees is a positive 90 degrees, that tells us that our turn is going to have to be in the counterclockwise direction. So again, what I'm going to do is I'm going to take my graph where I've plotted point P, and this time I'm going to take and I'm going to turn my paper 90 degrees in the counterclockwise direction. So still counterclockwise, but this time we're only going 90 degrees. So go ahead right now, take your paper, turn it 90 degrees counterclockwise. Okay, got it? What we want to do now is we want to write down the coordinates of where point P ended up. So I'm looking at the paper that I have next door to me, and after a rotation of 90 degrees counterclockwise, it looks like the new coordinates of point P are going to be 3, 4. And therefore, the coordinates of P prime are going to be 3, 4. Okay, go ahead, flip your paper back right side up. And now that you've flipped your paper back right side up, you can go ahead and plot point P on the coordinate plane. So there's point P double prime. Okay, and the last one, it's asking us to find the image of P triple prime, which is going to be the image of point P after a rotation about the origin of 270 degrees. And again, just a reminder that that 270 degrees, because he's positive, is going to go in the counterclockwise direction. So once again, I'm going to start with my paper. I'm going to turn my paper now 270 degrees, which would be 3/4 of the way around, 270 degrees in the counterclockwise direction. And what I really want to know, where did point P end up? What are the coordinates of point P? So if I look at my paper, it looks as if point P ended up at -3, -4. Once I write down the coordinates, now I'm going to go ahead and turn my paper back right side up again. And -3, -4 is going to be over here in the third quadrant. And those are the coordinates of point P triple prime. All right, so if you're big on steps that you can follow, a list of steps that you can follow for finding the coordinates, I would start by plotting the original point. My next step would be to turn the paper. And this is really how I can tell whether kids are doing this right or not. If I watch you in class and I see you spinning your paper around and around, that's a pretty good indication to me that what you're doing is correct. If you're not turning your paper at all, that's an indication to me that you need some help with this. So turn your paper the required number of degrees. And record the coordinates of where the point landed. And it's really important that you write down those coordinates before you flip your paper back right side up. And then lastly, return your paper to the original orientation. And plot the point from step 2. All right, let's go ahead and, as always, I'm going to have you summarize in your own words the key understandings and important takeaways from the video. And then let's see what you can do as far as rotating the vertices of triangle ABC on the grid provided in number 2.